Hello everyone. Today we are going to study about polynomials from our maths chapter for class 10th. To understand polynomials or the geometrical meaning of the zeros of a polynomial, which is there in your portion, we have seen that a polynomial takes different values of the variable. Let's consider the example px, which is equal to 2x minus 4. So we are considering this equation or px, that is the p is basically the function of x. So we have the different values as follows. Now if we take x as 1, so we are going to get, or if we substitute the value minus 2, if you see it on the screen, after substituting the value, what is the value we are getting here? So if we take x as 1, so x as 1, so substituting the value x as 1, we get 2 into 1, 2 minus 4, which is minus 2. So likewise, you can take different values, right? Value 2, 3, 0, minus 1, half. Here I've taken different values. What you can do is, you can take 2 positive and 2 negative values. Now by taking the values of the variable x and the corresponding values of the polynomial px as ordered pairs, now when we say ordered pairs, children, you please need to remember that it's x, y. So x always comes first and then y. So we can plot the points on a Cartesian coordinate system. Now by joining such points corresponding to the given polynomial, we get the graph of the polynomial. So what is the first thing you have to do? You have to put those values in the equation, what you can see it on the screen. So these are the values which you have to substitute in the equation, and then likewise the different ordered pairs are corresponding to the polynomial. So you get all these coordinates. If I highlight with this, you will find these are all the coordinates. And then let's see the graph of the above polynomial. So you are going to get the straight line. Can you see these, students? So these are the coordinates and you get the straight line. So very important that your values which you are putting, the numbers which you are putting in the equation, they need to be very right. If you get the wrong values, even your graph gets wrong. So in general, the x-coordinate of the point where the graph of a polynomial meets the x-axis is the 0 of the polynomial, which you have to remember. Hope this point is clear to everyone. So now in the same way, we can plot the graph of a quadratic polynomial. Now when we talk about the quadratic polynomial, I believe everybody knows that quadratic equation or the standard form of the quadratic equation, which is given in your textbook very clearly. So you can refer your textbook as well. So it's ax squared plus bx plus c is equal to 0. So that's the standard form of the equation. For example, if we take px is equal to x squared minus 4. So now what you have to do, you need to substitute the value. So let's say take x as 1. So if we have taken x as 1, so what are we going to get? We get 1 square minus 4, which is 1. 1 square is 1. So 1 minus 4 is minus 3. Hope this is clear. We can take one more value to understand. So x is equal to minus 1. So what do? You substitute this. See this one, this value. Can you see that minus 1? So you need to substitute the value minus 1, which is square minus 4. Now when it is minus 1 square, that means it is what? It is 1, right? So 1 minus 4 is equal to minus 3. So you need to remember one thing, whether it is 1 or minus 1. So for the square of the number, it's always positive. So the corresponding points are 1 minus 3 or minus 1, 3. 1 second, students. I'll quickly erase this to help you understand. Yes. So the corresponding points are 1 minus 3, minus 1 minus 3, 2, 0, minus 2, 0, 3, 5. So by plotting these points, we can get the graph as this, what you can see it on the screen, right? So you get the parabola. So the parabola is basically, you will be studying more in detail in the higher grades, that it is related to the coefficient of x squared. So here we find that our parabola, if you see this, I can mark it here, our parabola is in U shape, right? If suppose the value was negative, then the parabola will be on the opposite. That means it will be inverted. Now here we can see there are 2 points where the graph meets the x-axis, and hence the zeros of the polynomial are x is equal to 2 and minus 2. So thus a quadratic polynomial can have at most 2 zeros. You can refer the previous slide again and you will understand that it have at most how many zeros? 2 zeros. So the shape of the graph of a quadratic polynomial is a curve which is known as parabola, which can be opened upwards, U, or it is opened downwards. So the number of zeros will be the number of points where the graph meets the x-axis. Please remember this. And the zeros are the x-coordinates of the point where the graph meets the x-axis. Okay, so you don't have to confuse yourself that what zeros are we talking about. We term it as zeros of the polynomial where the graph meets the x-axis. Now, in fact, for any quadratic polynomial, ax squared plus bx plus c a is not equal to 0. So the graph of the corresponding equation y is equal to ax squared plus bx plus c has one of the two shapes, like either it is open upward or it is downward. Hope this point is clear to you. So this is very clearly mentioned in your NCERT textbook. So even you can refer the textbook and read it again. That will make more sense to you, depending on whether a is greater than 0 or a is less than 0. So these curves are called parabola. So request even you can refer your textbook and go through these slides again. Now, very important part is that the shape of the graph of y, which we are discussing, y is equal to ax squared plus bx plus c. So here the graph cuts x-axis of two distinct points, a and a dash. So I'm going to mark it and show it to you. See, this is 1 point. Can you see this coordinate? This is 1 point. We'll use the other color, and this 1 point, right? So the x coordinates of a and a dash, they are the two zeros of the quadratic polynomial. So it is cutting what? It is cutting the intersecting on the x-axis. Look at the second case. Here the graph cuts the x-axis exactly at 1 point. Now it is cutting at 1 point. I'll mark it with this color, if you can see on both the graphs. So point A and A dash of case 1, they coincide here to become 1 point A. The x coordinate of A is the only zero for the quadratic polynomial ax squared plus bx plus c in this case. Here the graph is either completely above the x-axis or completely below the x-axis. So it does not cut the x-axis at any point. That means it is not touching the x-axis. Can you see that? This graph and this graph. So the quadratic polynomial has how many zeros here? Hey, there will be no zero in this case. Hope this is clear. So it does not cut the x-axis at any point. So the quadratic polynomial has no zero in this case. Hope students, this point is clear to you. So quadratic polynomial can have either two or distinct zeros or two equal zeros or no zeros. This also means that a polynomial of degree 2 has almost 2 zeros. So you can remember this point as well. So in other words, any polynomial of degree 3 can have at most how many zeros? 3 zeros. Now, students, you also have to remember this, and that in general, given a polynomial, suppose px of degree n, the graph of y or px intersects the x-axis at most n points. So therefore, a polynomial of degree n has at most n zeros, as we have discussed in the previous slides. So thank you so much. For the next part of this chapter, polynomials will be shared and uploaded soon. Thank you. God bless you all.